Hi, Algebra. Welcome to 1.8. Represent functions as graphs. Of course, graph paper is going to be necessary. I do have a lot if you need some. If you do have graph paper, keep that at home. If you need to do some practice at home, because I have a lot here, it's really up to you. I can use functions in real life situations, and I can represent functions as graphs, our learning targets. Today we're going to have a warm-up. I want to evaluate the expression, meaning I'm going to substitute these four values in for x for both of those equations. My recommendation is to do them both in table form. So for instance, for part A, I have the x values, my domains, 0, 1, 2, 3, and I want to substitute them in. I'm going to probably do that here over on the side. So when I want to substitute in, I have y is equal to, instead of x, I'm going to write 0 plus 3. So the y value is 3. Then I want to substitute in 1. Y is equal to 1 plus 3. 1 plus 3 is 4. Substitute in 2. Y is equal to 2 plus 3. And you should see a pattern here because this is a linear equation. They show patterns. Y is equal to 3 plus 3. I'm substituting in for x here. I'm going to get 6. Now let's do B. A little bit more complicated. I'm actually going to do this one in black pen so it doesn't blend in. So I'm going to substitute in my domain, 0, 1, 2, and 3. And let's plug it in. Y is equal to 2 times 0 plus 1. 2 times 0 is 0, plus 1 we get 1. Y is equal to 2 times 1 plus 1. 2 times 1 is 2 plus 1 is 3. Y is equal to 2 times, now I'm substituting in 2 for x. 2 times 2 is 4, plus 1 is 5. And again, I'm hoping you see a pattern here. Any wild guesses what this next number is going to be? Yep, 7. This is important because we are going to be making a lot of tables in order to graph them on a coordinate plane, an x and y axis. It doesn't take that long. Notice I am writing out my work. If you make a mistake, I'll take a lot of credit off if you don't show your work. If you show your work, then I'll take just a little bit off. All right, let's look at this one. Graph the function. And this is going to be crazy because look at this. I have a fraction here with a denominator that's a 3. So when x is equal to 0, 1, 2, 3. So I'm going to plug in 0, 1, 2, 3. For now, leave these two blank. And I'm going to show the work. We have y is equal to 1/3 times 0, because I'm substituting 0 in for x, minus 1. Anything times 0 is 0. Minus 1, I get negative 1. Now I'm going to plug in 1. Y is equal to 1/3 times 1. 1/3 times 1 is 1/3. Minus, look at this. 1 is the same as 3/3, okay? Because if you take 3 divided by 3, you get 1. I wrote it out like this so I can have a common denominator. Now when I subtract across the top. Keep your common denominator. So negative 2/3. Substitute in the next one. Y is equal to 1/3 times 2 minus 1. 1/3 times 2. This is the same as multiplying across the top and bottom, the numerator and the denominator. I have 2/3 minus, again, I'm going to change this to 3/3 so I have a common denominator. 3/3 is the same as 1. And I'm going to have negative 1/3. These will be fun to graph. And now let's substitute in 3. Y is equal to 1/3 times 3 minus 1. These will cancel and I get 1. 1 minus 1. And I know some of you want to put a 0 here, but remember, these cancel. I still have that 1 there. And I get a 0. All right, so now when I graph these, I'm going to show you something. 0, negative 1. It's a dot right here. Go over 0, down 1. And then I'm going to go over 3, up 0. These values are going to be in between. Go over 1, down 2/3 is kind of tough to do. Go over 2, down 1/3, kind of tough to do. Draw a line. Notice I'm using these two big dots. Now why did I leave a space? I left a space because of this 1/3. 3 goes into what numbers? Well, look at this, came in nicely because it became 0. 3 goes into 3. Let's also put a 6 and a 9. Because my denominator is a 3, substituting 6 and 9 will actually make a lot of sense. Because if I have y is equal to 1/3 times 6 minus 1, 1/3 of 6, that's equal to 2. Because remember, you multiply across the top and across the bottom, they'll divide. You get 2 minus 1, that's equal to 1. So let's go over 3, 4, 5, 6, up 1. Oop, my line's off a little bit. Let's make the dot really big so you can't tell. And then let's substitute a 9. Y is equal to 1/3 times 9 minus 1. 1/3 of 9 is 3. 3 minus 1 is equal to 2. So see how these numbers came in really nice? Because 3 can divide into them nicely. So if I went over 9 up 2, my line's really off. I've got to make that really big. All right, so if you see a number in front of x that has a fraction, I recommend changing your domain values. All right, so now let's look at this one. The table shows the average Wisconsin SAT math scores from 2010 to 2014 as a function of time in years since 2010. In the table, 0 represents 2010. This will be 2011, 2012, 2013, 2014, etc. And graph the function. All right, so if you'll notice, these scores are just above 600. So what I'm going to do is I'm going to mark this as a 600. And I'm going to skip this one. That'll be 601. We'll write 602, 603, 604, 605, 606, 607, 608, 609, 610. I don't need to do any more than that. Okay, and then I'm just going to put 0 here. I'm going to skip 1. 1, 2, 3, 4, 5. All right, so basically what we're doing here is making a scatter plot. Okay, when you're given data for x and y, and you're just expecting to substitute them in. All right, so at 0, we have a score of 603. So at 0, I'm going to go up. 603 is right there. You just put a dot. At 1, we have a dot at 602. So that year, the scores went down. And then we went up to 605. Big jump. I'm always afraid I'm going to do these wrong because of the lines. And then we go back down to 604. So you'll notice every year there's not a big change here. And then 608. Woo! Good score. This is just for the math portion. There's a verbal portion also. You can connect them if you choose. I think it shows more of it. You can see trends better that way. But that's a scatter plot. So far, so good. Also, we should always title scatter plots. Wisconsin SAT. These are tests that you'll take when you're planning on going to college. Math from 2010 to 2014. Of course, this would be the years. This would be the score. So therefore, I labeled everything. All right. So now let's flip to the next page. And if you'll notice, I already have, oop, I made a mistake there. I have dots already lined up, okay? So sorry that I photocopied it before I put those dots on there for you. But what we're going to do is now see the dots already made, or the function that's already made. Let's see if we can find the domain and range. All right, so the first thing you're going to do, we all know that your x values are domains. And the y values are your ranges. So what we should do is look at each point. This is the point. We have to go over 1, up nothing. So this is the point 1, 0. And then check out this point. We had to go over 1, 2, 3, up 2. And then for this one, over 5, up 4. Hopefully you see a pattern here. And over 7, up 6. So they want us to write a rule that represents this. Not sure how good you are, but there's something called y is equal to mx plus b. This stands for our slope, which are basically directions. and this is your y-intercept. This is where it crosses the y-axis. So what I want to do is kind of connect this. Let's see here. It's going down 2 over 2, down 2 over 2. And let's just try to figure out what that equation is. Now, usually, the slope is the first thing, or the intercept is the first thing you want to do. That's where it crosses the y-axis. That's why they call it the y-intercept. So this crosses the y-axis right here. This is -1. I'm putting in a black dot. That's really important. Now the slope would be your directions to go from one point to the next. One point to the next. Let's look. We have to go up 2 over 2. Up 2 over 2. So 2 over 2x. Of course that will reduce. But that's our slope. Now, slope stands for rise over run. Okay, so we had to go up 2 and then we had to go over 2. It's positive if we go up. It'll be negative if we go down. And then usually we're going to the right. Once you get a really good hang of the slope, then you can actually go in other directions. Example 4. So I have 2 gentlemen here offering me some treats. It must be a birthday. Happy birthday. All right. Thank you. Now let's look at example 4. The graph shows population of Los Angeles from 1950 to 2000. Describe the population trend over the period, and how would you expect the population to be in 2010 compared to 2000? Okay, this graph is really tiny. So this is the population in LA. It's going from 2 million people, and then we have just over 3,500,000 people over in 2000. So basically, what I would say is it's increasing from about 5,000 people, if you ever written 5,000 to 500,000 people and 200,000 people every 10 years. That's a lot. It makes you wonder how one city can sustain it. So, just the reason for it is, to go from here to here, we had to go up 500,000. From here to here was about 250,000. From here to here, same thing. From here to here, about 500,000. And from here to here, about 200,000. So it is increasing every 10 years. So what would you expect in 2010? I guess we can look it up now. In 2010, the population can be, well, what do you think? If it increases anywhere from 200,000 to 500,000, somewhere in that range, well, let's go from, let's see, maybe that's 3,700. To about, I don't know, 3,700,000 to about 4,200,000. I don't know. Look it up. But that's kind of like just a suspicion, maybe. All right. Now, summary. I know I left this all blank, but just to kind of remind you, there's different ways to represent a function. You can represent it verbally, such as the output is 3 less, I'm just doing an example, than twice the input. Sorry about writing cursive. I gotta stop doing that. So what would that look like in equation form? 3 less, remember you give a space, put -3, twice the input would be 2x. What would that look like in a table form? If I substitute in values, pick out anything in a domain. Remember, these are your domains. And substitute it in. 2 times 0 is 0, minus 3. Now let's substitute in 1. 2 times 1 is 2, minus 3. Now let's substitute in 2. 2 times 2 is 4, minus 3. And hopefully you see a pattern here. Substitute in 3. 2 times 3 is 6, minus 3. And what would that look like in graph form? 0, -3 is this point right here. Then 1, negative 1. So over 1 and negative 1 right there. 2, 1. Should be a straight line. 3, 3. I think I did a pretty good job there. What do you think? So draw your line. So these are the different ways to represent a function. Here's the homework assignment for 1.8. We will be doing this in class. Here's your standard. And everyone have a really nice evening. Finally, we broke that heat wave.